So good morning everyone. Today we are going to start the meteorology, how the meteorology works at Earth surface and the importance of meteorology in dispersion and transportation of pollution. So is there anyone who knows something about the meteorology, how the large scale meteorology happens in the atmosphere or in Earth atmospheric system? Okay, just we will start like what kind of wind pattern we see in India. Can anybody say if you have any idea like seasonally how the wind pattern changes in India? Anyone that you know at least, right? What is the direction of wind during monsoon season? What is the direction of wind during, say, you can say winter or post monsoon season? Okay, so let's start. If you are not willing to answer, let me start the meteorology. So we know that the Earth's surface is. So don't mind my drawing, okay? I don't draw on this every day. So this is the Earth's surface, but our Earth is little like it's like a ellipse, right? It's a bigger. Oh, I'm sorry. Control set. Okay, I will use this. So I will try. Oh, what happened to this? Why this? Okay. Yeah, this is the problem. That is why I don't prefer this whiteboard. Okay, it's kind of elliptical. We have largest diameter at equator, then smaller at 60° south, and then further smaller at 30° south. Similarly, a smaller diameter or a smaller circumference at 60° north, right? And further smaller at 30° north, right? Can you hear me? I just want to make sure
Yes,
you
ma'am.
okay. So now
Yeah.
what will happen? We have largest diameter at equator. That means largest circumference at equator, right? What does it mean? That uh, the circumference at the equator is say something. What is x or y? X equator is, and this is the circumference at 60°, x 60. So x equator is greater than x 60 north, right? Now what will happen? The earth rotates and it completes one rotation. Can you see the whiteboard? In
Yes, ma'am.
24 hours, right? In 24 hours it completes one rotation. That means that this largest part also rotate same distance in 24 hours, and the largest distance in 24 hours, while the upper part, which is the lowest distance, also covers the one rotation in 24 hours. That means this part is the velocity wise, the equator velocity at equator would be greater than velocity at 60° north, right? That is why that is only when like the whole earth will, all the part of the earth will uh, cover or complete one rotation in same time, right? Is that clear? Is there any
Yes,
doubt?
ma'am. Yes.
Okay. Now what will happen then? Okay, don't message, okay? Don't. Why are you messaging so many times? What is the reason?
Ma'am, actually, the whiteboard was not visible to some people.
How come it's not visible to some people?
Now it is visible. They just had to zoom out.
Oh, okay. Okay, okay, then stop chatting because it makes noise. Okay, now in that case, we know that this any say you know the fundamental that if a train is moving in some direction at higher speed, okay, and the other train is also moving in the same direction, but the speed is low. This is say V1 and this is say V2. V1 is greater than V2. Then what will happen? For the person who is sitting in this train which is at higher speed, it looks like that the other train is moving in opposite direction, right? This is what happens. Or even if the stationary things are there around us, then we think like it is actually moving in other direction. Okay, when V1 is greater than V2, the person who is sitting in V1 or the train 1 will think that the things are moving or the second train is moving in the opposite direction, right? And similarly, the if the person who is sitting in a is still like slower train, say this is the third train which has the velocity v3 and v3 is less than v2, means v2 is greater than v3 whatever, then again what will happen, the person who is sitting here in slower train, it anything like this train or anything in this direction will look like it's moving faster in this direction, right? So this fundamental is same we can apply on earth rotation, and we can understand the wind pattern on the earth. So say when equator is moving at the faster rate, and earth always you can say move from west to east, so its direction is always west to east, okay. Oh, I don't know what is this. It's not control Z also. So it's moving in east direction. Earth rotation is from west to east in anti-clockwise direction. While uh, the wind, so when the wind which is coming from 60-degree south to 60-degree north towards equator, it will look like that it is moving in the opposite direction of the movement of the earth at equator. So see, um, the train which is here, say, right, which is moving at lower speed, for this the person who is sitting at the equator, he will think that the whatever the things or the wind, it is going towards the opposite direction of its movement, his movement, right? So this wind are called the south east trade wind. Okay, I will show you the figure also. Similarly, when similar pattern we can observe in northern hemisphere, this when any wind is moving from northern hemisphere towards equator, it will look like it is bending towards western direction. So this is known as north east trade wind. Okay, now come to the other part, which is like 30-degree north and 30-degree south, or 30-degree 60-degree south. Similar pattern we can see in the northern hemisphere. So in this case, uh, this 60-degree south is moving faster than this 30-degree 1 minute. Someone is in lobby. Then this, can you see my pointer? No.
No, ma'am, we cannot see your pointer.
Okay. So can you are not able to see the pointer?
We are just able to see what you are writing, but not the pointer.
Oh, okay, okay, okay. When I am writing. So again, what will happen? This part, which is 60 degrees south, is moving faster than 30 degrees south. Okay. So whenever wind is coming from like 60 degree east, 60 degree south towards the 30 degree south, what will happen then? What will happen? Can you explain similar to what I have explained here? Is that clear what I have explained about southeast trade wind?
The
Anyone?
wind will move in northwest direction.
Trade wind move in northwest direction. Yes, fine. But do you understand why is this so?
Can you
Yes, ma'am.
explain again?
Ma'am,
Like,
this is because of the Coriolis effect.
Yeah, I know it's a Coriolis effect. So don't search on the internet and tell me what is this. I know it's a Coriolis effect, and I would tell you, but I'm just asking you if you understand how this effect is on the Earth's surface.
Velocity at 60 degrees
So
south will be less than velocity at
this
30
is what
degrees
I
south.
explained, right? So velocity at equator would be highest. Velocity at 60 degree north or south would be lower than equator, and velocity at 30 degree north or 30 degree south will be further lower, and at pole velocity is almost zero. Okay. Now why how this, so the earth is moving from west to east, which is anti-clockwise direction. Therefore wind, we appear the wind is moving from east to west. Now why, how it will be like in the region uh, between equator and 60 degree north or south. What would be the wind pattern? This is what I am trying to explain. So we can understand it in a way that if somebody or one train is moving, or two trains are moving, one on equator and one on 30 degree 60 degree south. Okay.
60, ma'am.
uh-huh.
Ma'am, is the position of 60 degree and north and 30 degree north interchanged? Like 30 degree should be closer to the equator, right?
30 degree north or 30 degree south,
30
it,
degree north and 60 degree north.
Oh, no, 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 no. Let me just see. Oh, maybe, yeah, yeah. 30 will come first and then 60 will come. Okay, fine. Yeah, I did that mistake. So, whatever. See, so what I am trying to say, let me make it again, or maybe like I will just rewrite it. Okay. So, I'm sorry. Sorry for this mistake. 30 and then this is 60. I'm sorry for this mistake. So, uh, this is again, this is 30. Okay, 30 south, and this is 60 south. Okay. So when we consider the equator, the region between equator and 30 degrees south. Okay. So what will happen? This 30 degrees south is moving slower than equator. Therefore any wind which is going from south, from 30 degrees south towards equator, it will appear to the person who is at equator that it is going in the opposite direction, because this person is moving faster. Okay. Similarly, when the wind is coming from 30 degrees south towards 60 degrees south, then what will happen? 60 degrees south, the person who is at 60 degrees south is at slower speed compared to the person who is moving at 30 degrees south. Okay? In that case, the person who is at 60 degrees south the wind will appear that it is going towards the east direction. Okay, towards east. To whom? The person who is at 60 degrees south. Okay, so this wind which is coming from 30 degrees south towards the 60 degrees south is called what is the direction of this wind? South, right? This is going towards the east, right? From west. It is coming from west and going towards the east. So this is called the westerly wind. Let me just can you see now my screen now, the presentation? Can you see the presentation now?
No, ma'am.
No.
Okay, let me just share the screen then. Okay. uh, yes, so can you see now?
Yes, ma'am.
Yes,
Okay,
ma'am.
Yes, ma'am.
this is what is happening. So uh, whenever the wind is going from the low or slower part towards the like a higher speed equator, then it seems like it is moving towards the opposite direction to a person who is at equator. Okay, when the wind is moving from again from the you can say the faster region which is 30 degrees south towards the slower region which is 60 degrees south, then what will appear to the person at 60 degrees south, that the wind is moving towards the east. So this is how the wind pattern changes between the two latitudes, equator 30 degrees south, 60 degrees south, and this is the large scale wind pattern, or you can say meteorology, that helps in dilution, dispersion of pollution, and also the transportation of pollution from one continent to another. Okay, fine. Is that clear now? And this effect is known as Coriolis effect. Is that clear?
Yes, ma'am.
Okay. So that is how the large scale movement takes place. Now come to the point where we should also know
Ma'am,
is the word. Yes.
ma'am, could you go back to the last slide?
Yes.
Ma'am, why, if we use the ideal gas equation, then P equals to nRT by V. So, like, the pressure will be higher in higher temperatures, right?
No. At a high temperature, PV is equal to nRT, right? So, temperature, it should balance with the P evaluate. I just let me write it. No, when temperature is high, the pressure will be low. The molecule will spread and they will have large, like a higher velocity. Kinetic energy will be high of that molecule, gas molecule, right? And therefore, it will the pressure will be lower at high temperature, right? 1 minute. So how come you are saying this? What is the point which
The
connects?
direction of wind will change from equator to the poles rather than from the poles to the equator then.
See, this is the rather than from poles to equator.
We are here showing that the wind is flowing from poles to equator, but maybe if the pressure is higher in the equator than on the poles, then the wind will flow from the equator to the poles.
No, the pressure is high at poles, right? And low at equator because the temperature at equator is high. So only like always the wind will blow from high pressure to low pressure. How will it blow from low pressure to high pressure?
Ma'am, like if we use ideal gas equation, then we have nRT by V as pressure.
Ma'am, but the volume isn't constant, right? How can
Yeah.
we say that by only taking P and T terms?
Make the volume will remain constant always.
Ma'am, the density will be changing, right? Because of different temperatures. How will we say that the volume would be constant? If volume was constant, then density would not change up. Density of the gas shouldn't change.
Density of the gas will change when you heat the gas. The density will change. I agree with that, but you know
Yes, ma'am.
that the total volume of air surrounding the earth surface will be constant. It will not change, no. Whatever the
Yes, ma'am.
mass balance will take place whenever the pressure is high at a particular area and the low at the other area. The wind will blow from the high pressure towards the low pressure.
Yes, ma'am.
And similarly, like when it's opposite, it will go in the opposite direction. So this pattern is actually explained, um, like you can say it's a overall all view of wind pattern. But whenever the pressure in in one continent or in a one region uh, builds up, then the wind will blow from that region towards the
Yes,
low pressure region. So
yes,
it's
ma'am.
not like I am explaining each continent how the pressure and
Yes,
wind direction changes in each continent. It's an overall picture of the wind pattern
yes, ma'am.
or meteorology.
Yes,
Okay.
yes, ma'am.
So
Ma'am,
is that clear now? Who was asking the question? Who is the person who was asking the question? What is your name?
Kunal.
Kunal. So Kunal, is that clear now?
Okay, ma'am.
No, no, no. Just means think about that. No, like whenever the pressure at a particular and equator, because the temperature is high, always the pressure will be low. And in pole, the temperature is low, pressure will be high. Okay. So, but see here, you see also the arrow from 30° north towards the 60° north in a opposite direction. The pressure at 30° north will be lower, right? Then 60° north, right? Is that clear, right? However, you can see the wind direction is shown from 30 to 60. So it's not like this is the only wind direction. This is explaining that this would be large at large scale. This will happen because of the rotation of the earth. There are various other parameters that will affect the wind or meteorology at lower scale or micro scale, you can say. Okay. In India, what are the wind direction during monsoon? It's always from south, right? Southwest, right? Monsoon comes from southwest direction. So it's always from southwest towards the north. What is the wind direction during January, February? It is always from northeast direction towards the south. Okay, so that is why we get two kind of rain during monsoon season. We get the rain because of the southwest wind, and during January, February we get the rain because of the northeast wind. Okay, so the pressure builds up in a different area, and it drives the wind as well as the cloud towards the continent, right? Is that clear now?
Yes, ma'am.
What is the wind direction during the winter in India? Just now I told you.
Northeast to south.
Yes, northeast from northeast in is direction. But in post monsoon season, it is from northwest direction. Okay, and that is why the pollution. See, when it is from northwest direction, what will happen? The pollution all from Europe, Pakistan, Afghanistan, even Arab Peninsula. That like some part of the northern part of the Arab Peninsula, you can say, it will come towards India. right? That's why we have very dangerous, you can say, the pollution level during post monsoon season, which is October, November, December, because the whole pollution from other continents are also coming towards India. While during northeast direction, when like January, February, and March, generally the wind blows from northeast direction, it brings some pollution from like China and like northern part of the continents. However, because it rains also, we don't find that much pollution, at least in February and March. Okay, January it's a polluted though, but in February and March the pollution gets low, right? During southwest monsoon the pollution is low, means we are getting the wind from southwest, right? We get the wind from southwest, which is like the pollution, it will not bring any like continental pollution, but it will bring the pollution from the Indian Ocean, whatever is built up over the Indian Ocean. However, this particular season we have seen that whatever is coming from Indian Ocean as well as the Bay of Bengal, it gets into Delhi, but at the same time, because the temperature is high, means like 30 degree, around 30 degree, and humidity is also high, there is a secondary formation of pollutant. Now, do you understand what is the link between like micro or micro? You can't say micro, but like the continental meteorology and the pollution transport. So that is how we can explain the transport of pollution and its formation over any continent. Now it's clear, no? Now, after knowing the wind pattern, we should also know about the atmospheric structure. So this is the atmospheric structure. On the left hand side you can see that there are seven layers: tropopause, or troposphere, stratosphere, mesosphere, thermosphere are shown, 2, 3, 4, but there are other layers. So there are seven layers scientists recognize on over the earth's surface. These layers are characterized by temperature and pressure, and they have their very unique characteristics, so that it is designed in such a way that they do not mingle with each other. Okay, that they remain separate from each other. So you can see the temperature in troposphere ranges anywhere from 10 degrees centigrade at the ground to minimum minus 60 degrees centigrade at the top. Okay, so the temperature is reducing with height, right? So the air parcel which is at the ground will be hotter than the air parcel which is on the top of the troposphere. That means what will happen, whatever we are emitting at the ground, it's lighter in weight, because it's a hotter and lighter in weight, it will go up, move up. But whatever emission happens in the tropopause because of the movement of any aviation, what aeroplane, etc., because this particular region is colder, the air parcel will be little colder and it will not come down. Okay, so we don't get pollution from up to down, from top to down, but we the pollution at the ground will go up and it will disappear, or you can say diluted in the atmosphere. Here then, above this tropopause you can see the layer which is known as stratosphere. The temperature here ranges from minus 60 degree, which is the lowest temperature, to um, maximum temperature which is around minus 10 degree. Pointer option, yeah. So around zero, or maybe like around 0 degree. So again, you see that whatever is emitted here, which is like in this region, will not come down, right? Uh, Here in stratosphere, the temperature is so high, but we don't have any kind of like activity in stratosphere. But there is a ozone layer which form in that stratosphere, right? This is the ozone layer height, which is from 25 kilometer to 30 kilometer. Okay, so that is how it is designed. Again, the temperature decreases in mesosphere, and then temperature increases in the thermosphere. So because of this opposite temperature trend in different layer, this layer these all these layers do not mingle with each other. So on the right hand side, you can see that all the Boeing or aeroplane, we fly around 15 kilometer from the Earth surface, and that is within like just above the tropopause. Okay, so that is why we don't get any pollution towards the downwind, down towards the Earth. Radio sonnet 18 to 30 kilometer, and this is how we use this physics, or you can say the dynamics of the atmosphere for our benefit. Okay, so yeah, so the clouds form very close to the earth's surface. They are within 5 kilometer of, or less than 5 kilometer, right, which are actually precipitable. So clouds which form due because of the nucleation of, or you can say condensation of water vapor on particulate matter and other particles which exist in the atmosphere. uh, they are precipitable and they form very near to the earth surface within 5 kilometer. So this is how our atmospheric structure is.
Ma'am,
So
what is the reason for the temperature variation not being so linear or unidirectional?
that is something I do not have answer. Why this, it is not linear. It is like this is what I understood, that because of this design, particular design which is given um, by the creator, the pollution does not mingle. This layers does not mingle, but there is no, I did not find any explanation why this is in this way. This is what scientists have observed, that the temperature is not linear and it's like moving. It's a linear in a certain part, but decreasing rapidly or increasing rapidly, right? You can see it's not like it's not linear. Certain part it's a linear, it's stratosphere, and even troposphere it's a linear. This is what we also from the derivation of, we also get that the temperature lapse rate in the troposphere is 10 degree, about 9.5 degrees centigrade per kilometer. Okay, so and that is used in all the calculation. So it's not like it's not linear, but you can see it's just remain opposite to each other. In each layer, the temperature lapse rate or decrease or increase direction of the temperature is like opposite, means it's a decreasing in one layer then increasing in another layer. Okay, is that what you asked, right? Is that clear?
Yes, ma'am.
So
I just wanted to know
this
the
is
reason
the
for the monotone.
explanation, but if you will find any explanation why is this so, you can share with the class, but I did not find any explanation regarding this. Okay, yeah. So probably I think that is because of the solar. I don't know, means because Earth is not it's a elliptical, right? And the atmosphere surrounding the Earth is also, it's not like a plane, means plain thing. It will have some kind of mass which is shaped in the same way. Then the sun has different distance from each layer of the atmosphere, right? the layer from tropopause will be different, the layer from stratopause will be different, and so on. So maybe that is the reason, but if I will find the reason,
Yeah,
I will.
ma'am, I just googled the reason. The reason is that the different composition results in having different specific heat capacities. So the solar radiation gets absorbed in different amounts at the different layers.
Yeah, yeah. So composition I have written here. Okay. So, but so yes. So solar radiation will be absorbed by different layer. That is true. And why? See, the composition of these layers are basically it's in tropopause only. It's a very complex composition. It has all kind of pollutant. We know it's basically oxygen and nitrogen. Mainly it's 79% nitrogen and 21% oxygen. But other than that, because we have other pollutants which are added by the different anthropogenic sources, the composition get complicated. That's why this whole fashion of temperature lapse rate changes sometime because of the presence of pollutants. The same thing we can also explain the change in the climate, right? There is a certain climate change pattern throughout the year. Four seasons we recognize. However, uh, if there is no pollutant, there would be a certain amount of energy which would be absorbed between the atmosphere troposphere part, and it will change with the season. But because we are having the pollution which is coming to the atmosphere, then what happens, some of these pollutants like organic carbon, black carbon, they absorb more solar radiation. So black carbon absorbs the radiation, organic carbon scatters the radiation back to the space. And because of these compounds which are present and their quantity is different, so we get warming, little warmer atmosphere compared to what it would be, and that is known as the radiative forcing of the atmosphere. Okay, so and at the same time, the organic carbon which is scattering back the radiation again to the space, um, that it caused the cooling effect in the atmosphere. Okay, then there is a third component which is greenhouse gas. The greenhouse gas increase the temperature near to the earth's surface. Okay, because they absorb the long wave radiation. So this all phenomena is working. You are very correct what you have told, that the composition, whatever atmospheric composition is responsible for absorption of solar radiation, and therefore the change in temperature, but this get disturbed because of the pollution. So stratosphere, we know that it extends from 45 to 55 kilometer, mesosphere 80 to 90 kilometer, thermosphere, this is very interesting part. The region above the mesopause characterized by high temperature as a result of absorption of shortwave radiations by N2 and O2. So again there is a N2, nitrogen and oxygen only in thermosphere, but it absorbs like large amount of shortwave radiation. Even in our troposphere we have N2 and O2, right? Basically, so they absorb the short wavelength radiation, but I think in thermosphere the absorption of this is more, because maybe it's a distance also matters over there. And the rapid vertical mixing, the ionosphere is the region of the upper mesosphere and the lower thermosphere where ions are produced. Where so above the thermosphere there is a just ionization. All the components are present in the form of ions because the temperature is very high in that region. Then exosphere is the last layer, because it's like very hot layer. Whatever molecules are there, they just escape from the gravitational attraction of the earth. So means it's kind of vacuum. So the uppermost region of the earth greater than 500 kilometer 1 minute. Um, and the molecules with sufficient energy can escape from the earth gravitational attraction. So these are the 3 to 5 layers. However, scientists say there are 7 layers, but I think like 5 layers are out of this 5 layer. Only two tropospheric and stratospheric air layers are very important to us. Okay, because that actually changes the meteorology and protects the earth's surface from ultraviolet radiation. Then at micro level, we we concern about planetary boundary layer, with the layer which is um, defined as in terms of distance is within 1 kilometer from the earth's surface. Why? Because in whatever happens in this layer in terms of pollution or that affects the earth's surface. Okay, above this layer the free atmosphere is there, which does not actually affect us much. So we basically bother about the planetary boundary layer, which is within 1 kilometer of the Earth's surface, and the height of this planetary boundary layer changes with season. During summer, the planetary boundary layer, because of the heat and dilution, the height is more. During winter, the height of the planetary boundary layer will be low. Okay, and that height itself known as the mixing height. So in summer, the mixing height will be or higher compared to winter. This is what you can say. Now, at the Earth's surface, what happens? Why there is a different micrometeorology at the Earth's surface? This is because of the mechanical turbulence and thermal turbulence that happens near the Earth. So, mechanical turbulence, wind speed at ground surface is zero, and it increases with the height due to the pressure gradient, because the pressure is low, right? This cause the shearing, which result in the random fluctuation of the wind speed and direction to overall average wind velocity. The eddies form due to the mechanical turbulence. Greater the wind speed, greater the mechanical turbulence, easier the dispersion. Okay, so this is mechanical turbulence because of the you can say gradient in wind speed at different altitude. There is a turbulence near the Earth's surface, resulting in eddies, and therefore the movement of the wind. Okay, thermal turbulence. The thermal turbulence is because of the heating of the ground surface. Okay, so that is another factor that affects the meteorology near the Earth's surface. So see, I'm not going through this mixed layer and all. These are the definition, and whatever I have explained till now, you will easily grasp this when you will read this particular slide. So there are different. This planetary boundary layer has been divided into different layers: mixed layer, surface layer, etc. This is just for your knowledge. You should have the knowledge of this. Maybe it will not be used in this particular class for calculation of like pollution dispersion or anything, because the pollution dispersion calculation we do using the this uh, Gaussian plume model, and this Gaussian plume model takes the stability class. The stability class means the stability of the atmosphere uh, using which is defined using the micrometeorology near the Earth's surface, and the parameters related to um, this meteorology has already been given, so we are not in this particular subject, we are not going to learn very detail about how this mixed layer means, no derivation about the how this mixed layer and surface layer or entertainment zone are taken into account in order to derive the Gaussian plume model. That is not the scope of this particular course. So but in order to like have the knowledge what are the different layers that has been defined based on their like their motion, convective motion, or like the layer which is very stable, which is near the ground, very like first layer near the ground is stable. Then the further layer we can define because of the motion of the gas in that layer. So that we will learn, but not the application of this part in derivation of Gaussian plume model or anything. Okay, so that's why I'm not explaining it. You can just go through this slide, you will understand it. Now mixed layer, I told you that the mixed layer height is very important, and it changes season to season. In summer the mixed layer mixing height or mixed layer height is high compared to winter, and that actually something which goes into dispersion model in order to know the concentration of various pollutant in the atmosphere once it is emitted from the source. So dispersion models are small scale models based on Gaussian plume model or other models that actually that actually gives you the concentration, atmospheric concentration of pollutant when you will put the emissions as a input. Okay, so you know that, for example, I'm just telling you one example. Say I know that from one power plant 200 microgram or 200 kg per year SO2 is emitted. If I will put this value in this model, it will run the Gaussian plume model or other model, and considering the atmospheric dynamics near the ground surface, it will give us what would be the concentration of SO2, concentration in terms of say gram per meter cube or microgram per meter cube in the atmosphere. Okay, so in each like one unit volume of air will contain say 20 microgram SO2. This is how it will give you the result. So mixing height is very important, because when you give the meteorological parameter to the model, then mixing height matters. So this is the formula to calculate the mixing height, where QD upon zero point 0.5 into theta, del theta upon del Z, and ZI mixing layer height, QD is cumulative day theta. Oh yeah, is the time is over? Okay.
No, ma'am.
Del theta upon del Z is temperature lapse rate of the atmosphere. Theta ml is mixed layer temperature. Theta surf is surface temperature. Okay. So this is how you can calculate the mixed layer height and the temperature of the mixed layer. Now we will start in next class that how the air parcel move in the atmosphere, because this is the fundamental which is also used in formation of or models such as Gaussian plume model, etc. That we need to know how, when once the air parcel is emitted from the source, how will it move, what are the different factors that will either allow it to move up or restrict it towards the ground surface. Okay, so and that is what is used, this fundamental is used to define the stability class of the atmosphere. Okay, so we will go through that in the next class, because it's a whole topic in itself, so I do not want to um, start it in this class. So let's uh, learn it in the next class. Okay, is there any question?
Hello, ma'am.
Yes.
Ma'am, I disconnected for 5 minutes in between because of some internet issues. Like that won't affect the attendance, right?
No, so in attendance, we will see. I'm not disclosing how long your attendance. At least 15 means. I think I will see 15 minutes attendance should be there. Minimum 15 to 20 minutes. 20 minutes there. Okay. In case if you have internet interruption in between, I will not consider that period. So overall from 8 to 9, minimum 20 minutes you should be attending the class. Minimum.
Okay, ma'am.
Because I know there is a problem of internet in other in many regions, but don't make it a tool in your hand. So just log in and go away, and then again come and log in and go away. Don't do it. Okay, if I will find that you have just 5 minutes class and then again went away, left the room, and then again came again like joined for 5 minutes, then I will decide what to do, because it's not that frequent. Like internet doesn't go that frequent. Okay, is there any other question? So let me just ask you. Um, so what is your opinion about today's class? Do you think the things I have explained are uh, okay, or I should improve the explanation? Just give me the fair opinion, because that in that case I will try to have better explanation next time for the. So uh, you can honestly say whatever you feel.
Ma'am, maybe improve a little bit. Like sometimes the explanations are not so satisfying.
Okay. So in what term? Like it's in terms of language it is not satisfied, or in terms of scientific explanation it is not
Ma'am, the
satisfied.
scientific explanation.
Okay. Okay. Now tell me, in this class, which part do you think is not explained well?
Maybe the part where we discussed about the temperature changes in
Temperature
the,
of the atmosphere,
yeah,
or that atmospheric structure,
yeah, like the variation.
variation in atmospheric temperature. Okay. Okay. Let me see. Maybe I will try to have better explanation next time, or maybe like no, if maybe in the buffer class if you need it. So let me think about that. Okay, so that is one thing you think it's not explained well. Now any other part which you think is not explained well?
Not that I could remember right now, like of earlier classes and all. But like today, this was the
Only
topic which I
just
felt.
tell me about this class, because earlier classes already they have gone. Was there anything very means very unsatisfactory in earlier classes? If you have any particular topic which was totally unsatisfactory, I can explain it again. Anybody like Kunal, Keshav, Ishan, Adarsh, Rashmi, was there anything in earlier class or the previous class which is not explained very well, and you think it's unsatisfactory, totally unsatisfactory?
Ma'am, it was difficult to follow your cursor on whiteboard. So maybe you can switch to some other medium while explaining some things on whiteboard.
Okay, 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 okay. No, actually, last. Okay,
Plus,
I
whiteboard is
will.
also not recorded, ma'am. So it's better
Okay,
if you
so
shift to some other form.
maybe we will go for Paint because Paint might be recorded. It's a screen share.
Ma'am, OneNote gets recorded.
Hmm.
Maybe we can use Microsoft OneNote.
Oh no, one okay, Microsoft OneNote. Okay,
Yes,
okay.
ma'am.
Let me explore that. I explored OneNote for making the notes, but I have not explored it for making all this diagram and presenting it. Let me explore that. Is there any other suggestion?
Ma'am, can't we use Impartance platform because the recordings will be recorded on its own there, and your whiteboard will be the content you covered over whiteboard that will be recorded as well.
In Impartus.
Yes, ma'am. That's really more convenient.
Okay. Okay, so let me note down the suggestions because I need it. Okay, so one suggestion is Impartus. Impartus.
Because
The
students find it more convenient to watch the recordings over Impartus than over Teams because it consumes less data as well.
okay, okay. Uh, the second suggestion is to use maybe I will use Paint in case Impartus I am not comfortable, but I will try to explore Impartus also. The third thing you have said that the meteorology, right? That atmospheric structure is not explained well. Atmospheric structure unsatisfactory. Okay, fine.
And
So I
from
will I
ma'am,
will
from
see.
next week, which 2 days will we have classes?
So from next week onward, we will have class on Wednesday and Friday. Fine.
Okay, ma'am.
Ma'am, can you please upload those lecture slides on Teams notebook? Only two lectures are present.
Okay, I will upload the lecture. Actually, I wanted to upload it yesterday, but somehow I couldn't do it. But I will upload it before like leaving for office.
Okay, thank you.
Upload lecture. Okay.
Ma'am,
Uh,
just a small suggestion. If it is possible to upload the lecture slides like before the lecture, so that during the lectures we can browse through the topics, because sometimes it happens that if you are teaching and I have a doubt in the previous slide, so it becomes difficult in the live class.
okay. Upload lecture even before class.
Thank you.
Okay, so fine. Imparters, I will explore. Whiteboard is not good. You are saying in a Microsoft team. Then, is there any variation in my voice because I am not using any headphone or microphone? Do you want like was there?
No, ma'am, your voice is fine.
Okay, voice is fine. Okay, atmospheric structure uh, unsatisfactory. Upload lecture before class. So, did I note down all the things, or is there anything I missed?
Ma'am, OneNote, Microsoft
Yes,
OneNote.
yes, 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 one. Let me explore these things and then I will get back to you with an option which is
मैम
this one. Yeah,
मैम
yeah.
मैम ऐसा हो सकता है कि मैम वो जो अटेंडेंस होती है ना मैम, अटेंडेंस को आप फाइल के रूप में अपलोड कर सकते हैं क्या?
किस लिए?
मैम हम लोग को भी मतलब पता रहेगा कि हम लोग का भी अटेंडेंस हो रहा है, क्योंकि मैम कभी कभी नेटवर्क कनेक्टिविटी की वजह से हो नहीं पाता है प्रॉपर।
कोई प्रॉब्लम नहीं, आपकी अटेंडेंस कंपाइल करके आपको दिखाई जाएगी
ओके ओके
probably
मैम, थैंक यू।
yeah, probably before minor one, then before minor major exam. Okay, so
ओके,
you
थैंक यू सो मच।
will come to know. Okay, so attendance, okay.
Ma'am, can we leave? There's another class.
Yes, yes,
मैम
yes, you can leave.
मैम
It's over.
मैम
Yes.
मैम आज मैम जैसे मेरा मैम आज पहला क्लास है मेरा, मैम टेक्निकल प्रॉब्लम हो गया था, इसलिए मेरा ये कोर्स मतलब कंफ्यूजन में था कि
हाँ,
इसमें दिख नहीं रहा था मैम, टीम्स वगैरह पे ऐड नहीं हो पा रहा था।
Okay.
तो इसके लिए मैम मैंने ई एकेड से बात किया था, तो मैम मेरा ये पहला क्लास है, आज से पहले का मैम अटेंडेंस का कैसा क्या है?
सो एक्चुअली मेरे ख्याल से 2 या 3 ही क्लासेस हुई है इसके पहले। आई थिंक 2
ओके
हो गए। तो डोंट वरी अबाउट दैट। उस जो भी है एड ड्रॉप के बाद जो भी अटेंडेंस है, जिन्होंने एड ड्रॉप के बाद किया है उनका उसके हिसाब से कैलकुलेशन होगा। ठीक है।
ओके 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 मैम। बिकॉज मैम वो ना 90% अटेंडेंस से क्या होगा कि हम लोग का मैम बेस्ट वन एक
हाँ
सीट
हाँ।
जो है ना कंसिडर हो।
तो आप वो उसके लिए कोई प्रॉब्लम नहीं है। जिन्होंने एड ड्रॉप के बाद ज्वाइन किया है उनका वहां से कैलकुलेशन होगा।
मैम एक्चुअली मैम मेरा क्या हुआ था ना मैम, मेरा ये सीवीएल मतलब आप वाला भी और कोटा शहर वाला भी दोनों में हो गया था, क्योंकि मैं बाहर था, मैंने एक फ्रेंड को बोला था ऐड करने के लिए, तो उसने मतलब मेरा रूममेट्स को, तो उनसे गलती से दोनों में ज्वाइन हो गया था।
कोई प्रॉब्लम नहीं, कोई प्रॉब्लम।
तो मैम उस वाले को मैंने रिमूव करने का रिक्वेस्ट डाल रखा है, इसलिए वो पड़ा हुआ है, अभी तक उसका सॉल्व भी नहीं हुआ।
वो आप डॉक्टर कोटा को एक मेल कर दीजिए, काइंडली रिमूव मी फ्रॉम योर क्लास करके।
ओके ओके
I have raised the general request. Well, this is what I think the student did with me. So I removed them from the class. I approved their removal yesterday only.
ओके ओके ओके, थैंक यू मैम।
Okay. So you can leave the class if there is no other issue. Okay. I have downloaded the attendance and I will upload the video on Impartus.
Ma'am, the same problem was with me too. I also, by mistake, added both the courses, and I raised the student general request, and as well as I mailed Kota sir. So he replied that he has no role in removing students, so I have to contact academic section, and they said contact course coordinator. So both of them are saying to contact each other. So
Right.
what should we do?
No. I think okay, let me see if I can talk to Harshakota, but you can explain to him that when we raise the complaint in ERP, then there is a two channel. Either the request can be sent back to student with some query, or it can be forwarded to dean academics or dean curriculum, uh, saying that okay, remove this student. So they will remove the student from the list. So this is what I did. I think I have uh, some of the general request I have sent back to the student, and some I have forwarded to dean curriculum, saying that kindly remove this student from my class.
Okay, ma'am.
Uh, Talk to him and explain him that these options are given in ERP.
Okay,
But
ma'am. I will mail
without
him again.
without coordinator's consent, this IIT people will not remove you from the class. Okay.
Okay, ma'am.
So,
Thank you.
okay. Thank you very much. Bye.
Excuse me, ma'am, please upload the recordings and lectures as well.